So we are going to talk about Vapor and SQL and how to use and get best practices. So my name is Sergo. I'm working as an iOS developer at Tandem. Tandem is an application for language learning exchange, so you could find a Tandem partner for learning a new language. I have an experience as well in backend. So before doing iOS development, I worked as a backend developer, and one of my projects was fully in SQL. So whole business logic was written in SQL in stored procedures in the database, and this project made me deep dive into SQL and understand how stuff worked beneath. And since then, as I already said, I'm working as an iOS developer, but I still do some backend on my side projects. And Vapor is making me bridge those together to be close together. And I was working on one of my projects. I want to give you an example right now. What was the idea of this talk and the inspiration? So one of the idea was that let's dive through the code directly. So in Vapor, if you have an object that you want to also store in the database with Fluent, you can have your object, and then you extend the model depending on your database, and then you can add your migration and the content to make it migratable. So when you make it migration, you can also write your own migrations, how to change the table when it tries to create it, or like roll back if something goes wrong. And content makes you return this model directly from the router, so you can return and respond to the API with this. And as you see here, we have the products, that's the children. So this is an example of the one-to-many relations. So the store could have many products. And if we look at the product model, it has store ID, and store is referenced with the store ID. And what I usually do when I work with ORMs is I always enable logging. So if you look at the third line, you'll see enable logging. So this is how you enable logging for SQL in Vapor. So with this, you can actually see what kind of queries is it generating and running on your database, and you will understand what exactly is happening if you want to look at it and optimize some of the queries. So when I did this and run the project, it gave me lots of queries, and what took my focus was this text here. So store ID, which was on the product, which is referring to the store, is not indexed by default. And before we go into the index, before we go to the Vapor related stuff, let's quickly review what an index is. So index is a data structure that allows to retrieve the data from the database faster, but on cost of the additional, so it will be slower to write new rows in the database, but retrieval would be faster. So indexes allow us to quickly retrieve the data without going through the whole database. So it will go directly to the whatever is our object, our row, and we'll return it. And we can create index on one or more columns. So we could have multi-column indexes. Internally, index has this kind of data structure. So it has a sorted list of the values, what's indexed, and then it can go through the, very similar to binary search, go through it and directly, without looking for all the objects, look for the item directly. So if you're querying on a database that doesn't have any index, and you are querying and you are filtering with this column, and if the column doesn't have an index, it will go through whole database to find it. I found a nice website which allows you to visualize some algorithms on it. And this is an example of the linear search. So this is what happens when there is no index on the column and we try to retrieve with it. So we try to look for 1000, but it goes one by one. It doesn't matter if it's inside or not. It doesn't have any additional information on top of it. It still has to go through one by one, and when it finds out that, okay, there is no more elements and the thing is not there, it will just say, okay, I could not find it. And the second one is to look for something that's inside the list. Again, it will go through all of it and find that, okay, it's here. We can also look at the P+3, which is the underlying implementation of the index, how it works on the same website. So this max degrees here allows how many nodes can be on the same level. It's a very nice website to visualize all the stuff and see what the difference is. So if we look for the, if we look for the value in this, you can see that because it's already sorted, it knows exactly where it should go. And even if object is not inside, it still knows that, okay, this data is sorted, and this on the top should be on the right side because this is bigger than the current value, and I know it's sorted, so everything else is on the right side. So each step it does this, and it avoids lots of the comparisons. And this is very, very important for the not only just single query, but especially for joins, because for joins you have multiple rows against each other joining, and you have to do the same for multiple rows. And at the end it becomes quite slow if it's not indexed. Now back to our sample. So if we wanted to get, for example, stores, then ID of the store and the product, so to get the products from the store, we could have something like this, where we first find the store and then query directly with the Fluent on it, or we could directly get the products with the store ID, and both of them write a similar queries. So top one writes both two, because first it needs to find the store, and the second one just writes the bottom one because it just needs a product. So as we know, those by default it's not indexed, so if it contains lots of the rows, it will actually be quite slow. And I was looking for the ways to do it in Fluent and Vapor, so I don't have to do manually on the database. And I'm going to show you that, but before we go into that, I want to show you the example. I'm going to show you the example with SQLite. To connect to the SQLite from the command line, we just try SQLite 3. So we are directly in the SQLite console right now. So it's very similar to the other interactive shells that give you all the ability to go through the code and do some analysis. Okay, so first thing what we do here is enable timer. So timer on means that each time we do some operation here, it will also give us a timing of this operation. So how much time it took, and we will be able to see actually if it's faster or not. So let's see some tables in here. So we have one table and it's called items. And these items have just one column and it's called number 1. So to see the indices on this table, we can and there is no index on the table. Now what happens when we get something from this table? So initially let's get some random value from it. To then query with this random, so it's not rigged and we actually get some data. So we got the random value from the database, and it took us 2 seconds, but doesn't matter for the random right now. What matters is when we actually try to get the value by this. So let's see if it actually is in the database. So our query took like 0.6 seconds. It's not bad. Actually, let's look at the amount of the. Oops. Oh, yeah, sorry. So we have around 15 million rows, and querying for a single row took us around 0.6 seconds. And yeah, it doesn't matter if it's in the table or not. Again, it's not in the table, but it still takes around the same time because it still has to go through the whole database to find if it's there or not. And because there are too many of them, it just cannot find it. So what we can do in all of the databases is there's a way to actually ask our database what kind of job is it going to do when we are going to run the query. To do this, we are going to query, and then we provide what kind of query we have. For example, and it tells us that to query this, it's gonna scan the table. So scan table means that it is going to go whole the table, and then we're gonna give us the result. And it actually even becomes slower if we try to sort, for example, and get like first 10 elements. So we got first 10 elements, and it took like almost a second to get the first 10 elements. We could again run the query plan analyzer. So and now it's saying us it's going through whole table again, and then it's going to use temporary B3 for order by. So what it's going to do is it's actually in memory going to sort whole our database and then give us the top 10 matches. This actually is, this syntax varies from platform to platform. So MySQL and Postgres could have different syntax, but all the databases support it. So it's actually a very nice way to understand the performance reasons. So, okay, now let's create an index on our single column. So we tell create index and name of the index, and then the table and what kind of column we want to index. We could have multiple indexes here. So initially it's going to take a bit of time because it will go through the database for each row, and it's gonna build the trees that we saw in the previous slides. And now if we actually run the same query, it's much faster. It takes 1 millisecond to return this same row. It doesn't matter if it's there or not. Both of them are quite fast. It's much faster. And like, for example, if it was an iOS application, you could even do it in a main thread because it's much faster than switching all the contexts. And now if we actually run the query plan, it tells a search table using this index. So right now it tells us that, okay, I'm gonna go through this index to search like table. So it's not gonna go through the table itself, but it's gonna use our index to get whatever result it wants. And I can do the same for this. Now you see because it's already sorted in the database, it doesn't need to sort it anymore. And if you run the explain query, it just says a scan table using this index. It doesn't have this temporary B3 that we saw before, so it doesn't need to sort it anymore. And just to show you that I'm not reading this, so let's drop our index. So we remove whatever we built right now, and when we do the same old query, it again became much slower. And if we run the query analyzer, again it uses temporary B3 because it again needs to sort rows to give us the 10 rows. Okay. So when I was working on this and looking for a way how to create an index on a table with Vapor, I saw this comment on the Discord channel. So this is actually quite a nice way to create directly from the Vapor the index. So again, you create the index and index name, and then you provide a column, like property, what column you want to be indexed, and then it will create a column. You can chain multiple on if you have multiple column index, and it will do the same. There is actually a quite interesting website. It's useindexlook.com, and this contains some blog posts about SQL performance and some of the optimizations. And they had very simple questionnaire. So questions, it was total was 5 questions, and question was like, if you have this index and this query and this query, is this index enough to cover both of the queries without going through all the database? And actually, I'm encouraging you to try out this website and do it yourself. It's quite interesting. The thing is, only 30% got 4 or more questions properly correct, and this means that people are not aware how actually indexes work and what's a connection between query and index and when it's going to use what. And this could affect the performance of the database in the application itself. And if you have iOS background, you can create the index in the core data as well. And for example, in the Tandem application, we have multiple indexes. One of them is about message ID. So if people have messages, and when we want to update single message, for example, if message was delivered or seen, or user wants to delete this message, we have index for this case that we search it with message ID directly, and we have another index that's user ID, user type. Users could be different types, and the date. So when you open your messaging with someone, it actually uses index directly, and your result, whatever you see on the screen, is very fast, and you don't have to wait. Your application is not lagging because of the slow database. And it's actually, if you know a bit about core data, there are many blog posts how bad it is and how slow it is. And I talked with someone who actually was complaining about the slowness of the core data, and I asked if they were using indexes. The answer was they did not know what an index was. And of course, then if you are gonna use queries on unindexed columns and you have lots of the rows in it, it's gonna be slow. And this was also one of the idea about this talk, that many people in Vapor also have iOS background, and on iOS you don't have to create indexes every day. And on the Vapor, on the database, whenever you create new model, it's or you're changing anything, your schema, you have to think about what is going to do with this. And some of the databases actually take it even further. For example, Google's Firebase has a new database, Firestore, and whenever you create a new document in it, it actually indexes all the columns by default. So there is no way to not index a column. It's gonna index it always. And if you're gonna write a query that's gonna use columns in a way that it is not able to use the index, it will actually not allow you to run the query. It will instead give you the warning or error, depending where you are in development mode or not. It will tell you, hey, if you want to run this query, please add this, and this index on this collection, and then we will be able to run this. So they calculated and said that retrieving the data with index was actually much, of course, faster with indexes, but additional cost that you have to maintain this data structure each time you insert or update something. They said that the overhead for this insert was much lower than overhead for retrieval without index, so they decided to do it. But it's not always the case. It depends on our usage, so just don't index all the columns. Use a query analyzer and see actually what your endpoint, what kind of queries are generated and used. And I wanted to see what were some of the patterns in Vapor applications, and I went through some of the popular Vapor applications on the GitHub and collected some of the samples I wanted to show you. One of the interesting patterns is that we have multiple queries where we could have one. For example, in here we first find store, and then we find products, retrieve all of them, and then create delete query for each of them. So this will first we'll retrieve all the rows, then we'll try to create a query for each of them to delete, and then we are going to run it. And if we have 100 products, we will need to write 100 plus 1 query for this. So like database has to execute 100 plus 1 query for this. Where actually Vapor and Fluent allow you to directly put a delete method on the query. So instead of returning the objects in the memory and then manually calling the delete, you can directly delete in the database, and the Vapor is gonna generate the proper query, and you can use this kind of code to directly delete those products in this case, and then delete your store. So instead of like, if you had 100 products again, instead of 101 query, we will always have the one query here, regardless of what's the size of the products. And this was actually very similar in many cases, where many times objects were retrieved just to delete them or update single property on them. And there is another update method on the query for Vapor and Fluent that allows you to directly update the column or like property without retrieving them. And you can also have multiple updates, so you don't have to query first the rows from the database, put it in your application's memories, and update and put it back into the database. You can tell the database directly that, hey, please update this to this, and it will do it in one query without doing all the overhead and round trips. And the same goes for the joins. So in our case, if for example we have one-to-many relations and we had like one store and multiple products, and instead of first querying for stores and then for each store querying for their products, we could use like similar to this, where you query on the parent and then join whatever you have and tell Vapor to also decode that entity, and in the end you actually get a tuple of these objects, and this again will only run one query instead of a number of stores multiplied by number of products they have. When I already created that, I actually found out this comment on the Vapor Discord channel. Someone was asking something about sorting the rows. They didn't ask anything about the query. It was just about the sorting. And with answer, someone replied directly with a proper value here. And this is exactly the same as our example, that we have actually joined authors with papers and decode both of the objects directly instead of going through the authors or queries papers and queries them manually one by one. So this will reduce our databases load by a lot. And I also noticed case where there was data retrieved just to use count on it. And in this case, it's probably not too much, because we could probably only have one row with this email. But if our query is a bit different and we could have lots of the other rows in it, we could actually get lots of the extra overhead because of this. And again, our Vapor has a count method, and you put it on the query and it will just return the whatever count would it return. So you don't need to return all the rows, it will just give you the amount of the count. And it's not only count, but you can have all the aggregation methods like sum, average, minimum, and maximum. And yeah, again, instead of going through them manually and doing it yourself, it's much easier to use this, so you can actually optimize some of the queries as well. So next pattern was pagination pattern that I saw as well. So in this example, we have product, and then we are filtering with store ID, and we have range. So range is depending on the page, so it generates like from this to this, the proper offset, and at the end it generates this kind of query. So this has multiple issues. The first is that we actually are missing the order, like sorting here, because if we don't provide what kind of sorting we want, and we want to paginate in it, there is no guarantee that next time when we ask for it, it's going to return the same order, because internally the database might delete some of the rows, remove some of their internal caching or actual data files to somewhere else, and internal list of the rows could be changed. So when you try to get a pagination, always use sort. If you don't know what kind of sorting you want, just use the primary key for it. Now it will generate the proper order by, so you would actually always get the same sorting. But this still has more problems. And first problem is offset. If we read PostgreSQL's documentation about limits and offset, they say that limit and offset give you ability to get certain range of the rows, that offset allows you to skip some kind of rows, and the problem is that rows skipped by offset still have to be computed by the database. So if we have lots of the rows and you're gonna skip a lot of the rows in it, you want to have 1,000 plus 20, it is still going to go through this 1,000 objects, count, okay, I'm going to skip 1,000, and when it reaches this offset counter, then it's going to get all the rows. So if you have lots of the rows, don't use the offset directly. This again has not only this issue, but this issue as well. So imagine you are getting like first 10 rows here, and then users go scrolling through the rows on the application or on a website, and there's a new row on the database. And you now want to get the second page of it. Now, because there's a new row in it, our last row is actually going to appear in our new query as well, because there is no deduplication of it. Our server doesn't know that it already sent you this. You just tell them that please give me these rows from this to this, and server is actually returning the proper values. And imagine if it was like not 1 but 10 new rows, then you would get the same result for the queries. And if it was more than 10, like your whole pagination will completely be broken. So in this case, what's a better idea is to use identifiers. So in this way, we tell that please give me the products after this ID and just give me 20. Here offset is always 0 because we know exactly where are we going to start from calculating. It's going to use index in our case, and it's going to go through our index and find this ID, and then because it's already sorted and it sorts by the same column, it's going to just get the next 20 rows in this case. So we don't have offset case here, and we also had the problem with multiple, like same row appearing in the multiple queries. But sometimes actually the previous one was something that you might be expecting. For example, if you have a website where you have like page 1, page 2, page 3, it's like many websites work like this. If you go to the second page and there was new post or new comment inserted in the database, you will see the last one from the previous page on the top. Sometimes this is what actually you want. So people are used to it in some of the websites, and sometimes you can have it. But if you have multiple rows, especially like if you have application or endless scroll, this is the way to go. It will give you the performance and like proper data manipulation. Another pattern was that some of the tables were queried in the memory, so they were retrieved by like filtering with a different kind of flags. So here we run the one query with filter true and then filter false. So what it means that we are gonna still have all the rows from it, but now we will just go through like 2 queries to get this. This is kind of tricky one because database could be indexed, like those columns could be indexed. So if we do it in memory in our Swift code to then generate like which one is active or not, we will have to go through all the returned rows, and database could give us directly the rows for true and false. But if we are gonna return all the rows in the memory, this table is probably not supposed to be indexed, because if you return all the rows in the memory, this means this table is very small, because you're not gonna get your you don't want your server to be filled up with your rows, because if it was like millions of rows, then it would actually return all the rows. So in this case, it probably still makes sense to do it in memory. It also, when you have lots of the microservices and when you want to scale your applications, usually one of the hardest part to scale is your database. It's very easy to just launch a new Vapor instance and it will just work and connect to the database and work, but initially you have one single database, and to scale database and have multiple database instances running is much harder, and it needs much more time. If in this way we kind of get some overload from the database and put it in our application side, it's also a good idea. We will somehow reduce the number of queries our database needs to handle, also the sorting part. So this will help a little bit. But there are some cases still where you still need to run the raw queries in Vapor. And again, Fluent allows you to do it. So this is one of the examples I took from one of the GitHub projects. So they use raw queries directly, where they have multiple queries inside, and just return it and then decode values. This using raw queries is not a bad idea if you know what you are doing. So Fluent gives you really nice API over the database. It also gives you type safety. So for example, if something was changed and it doesn't return the same type, Fluent will not allow you to do it, or Fluent will actually decode the proper type. But here you have to do it manually. You have to make sure that the names are the correct and so on. So if you're going to use a raw query, make sure you use it properly. One way to actually help this is to define your model like this, make it codable, and then use a connection. You use raw query and then ask it to please decode this this struct from this query. And in this way, you at least have more guarantees and you have a better way to use this model. This kind of approach is very interesting, actually, not only for this, but you don't have to have the same model in your database, and you don't have to return the exact same model from your endpoint. You could have the different model definitions. This will allow you to change some of the internal implementations and still return the same model to the client. So for example, again, if you have multiple microservices and you want to change some of the structure internally in one of them, if you change this internal structure and this is the exact same structure that you return, now all the microservices have to be updated so they know what kind of data structure this new microservice returns. But if you use different structures for internal use and for external use, you actually can just change internal implementation and always return the same for external usage. Many people already use this kind of approach. One of the very simple approach is for the user object. Users usually have some kind of password, but when you return user list, you don't return password with them. So you could take this advantage with other models as well, and just return what our client actually needs and decouple your internal implementation from external expectations from the client. And going through some raw queries might give you some better ideas as well, because queries and databases are actually very powerful, and you could use some of their internal methods to accomplish something. For example, you could create triggers that runs each time you update or insert a row in the database. So for example, if you wanted to create the log for the row and you wanted to know exactly when was it changed, what was changed in it, you could create the code in your application where you have to make sure that each time you change it, it also needs to create a new row in the database. Each time you update, it needs to create a database that will run each time the database will actually change the row. It will be much easier, so you won't have to do it in your application. So summary is that learn SQL. It's very simple. It's very easy to learn. If you already know Swift, it's much easier than Swift. I would say in 2 weeks probably you could learn quite on an advanced level, and then you will be able to do you would understand a lot more about queries. Log and measure your SQL queries, because most of your endpoints will probably run some queries, and some of them will run more than one queries. For example, you could have authentication query, you could have then actual logic, you could have multiple ones. And if you log and then measure actually what is my endpoint's query, what kind of query is it generating and what time it is taking to run this query, what kind of plan is it using, so is it actually using index or not, then I can optimize my endpoints properly. If I see that one of my endpoints is actually quite slow and returns a response very, very slowly, I can just look at the queries it generates and then see if it actually is a problem with the database, if I can somehow make it even faster. So I don't have to go and directly get the biggest server I can find. Then once we find out which queries and columns are used mostly, we can add indexes to it. Again, you don't need to add the index to each column. It's not a good idea, but you have to find what's the best usage of it. If you have multiple columns in the same query, add the multiple column index. So it will use the index directly and will return the result directly. But again, you have to think how this database and rows and queries are used. For example, you have too many writes and not too many reads from this table. You might be good without index, because if you are just inserting in it, as we know, index will slow down our inserts. So if 90% of this table is about indexing, and then we just return it for some logs or maybe for some data warehouse, it might be better to just don't add indexes and don't slow down our inserts and updates with it. So make sure to run queries, analyzers. Again, all the databases support it, not only SQL, but other MongoDB and other NoSQL databases also support indexes and query analyzer, so they will tell you what kind of queries they are going to run and how you can help them to find the result faster. Next, my suggestion is know your tools, again, to make sure that whatever you are doing, maybe there is already a better way with the tool you are using. For example, maybe there is a better way to create the index with Fluent. When I used it for the first time, I went and created the index manually on the database because I didn't know there was a way to create index in the Fluent. But then I found out, and now I can use it directly. Know your tools, so you know that if they add or change something, you can directly use it, so you have less overhead to go to the database manually, or then each time you create a new database for testing, for production, you have to do this manually. So if you know like what kind of functions does Fluent provide, so this aggregation, count, and all the other stuff, it supports joining, and you can decode multiple objects and multiple structures from it. So it gives you many abilities. So knowing what kind of abilities it gives you is a good idea. Also knowing your SQL or NoSQL servers abilities is a good idea, because they have very different implementations. Even MySQL has internally different storage engines, and they work differently. So knowing what you are using and how to take advantage of them is always a good idea. And if you are not joined to Vapor's Discord channel, please do it, because it's really the best resource to find out about all the Vapor stuff. You could ask any question about anything related to the Vapor. There are actually some channels that's not Vapor related. If you want help with iOS, for example, there is a chat for iOS as well. So it will give you a really good idea. You will always be up to date when there is a new Vapor release, when there is a new Fluent release. You will be up to date with. You will read all the release notes, and you will know that okay, there is a new thing added or removed, so I can use this in my production code. And that's it. Thank you for listening. And if you have any questions.